Myself, Dr. Dinesh Kumar, lecturer physics, Government Victoria Girls Senior Secondary School, Patiala. The topic which I am going to explain is mass defect and binding energy. Nuclear binding energy. For stable nuclei, the mass of the nucleus containing n neutrons and z protons is less than the total mass of n isolated neutrons plus z isolated protons. The mass of the nucleus is always less than the sum of the masses of constituent nucleons in their free state. This difference in the mass is called mass defect, which is denoted by delta M. The energy equivalent to mass defect is called binding energy of the nucleus. The binding energy can be found by finding the mass of the nucleus and subtracting the mass of the same number of isolated protons and neutrons. Binding energy of the nucleus is given by binding energy is equal to delta m into c square, where delta m is the mass defect and c is the velocity of light. Binding energy in ergs is delta m in gram into 9 into 10 the power 20. Binding energy in joule is equal to delta m in kilograms into 9 into 10 the power 16. If mass defect is in AMU, then binding energy is equal to 931.5 mega electron volt. If Z and A respectively represent the atomic number and mass number of a nucleus, the binding energy of the nucleus is given by binding energy is equal to Z MP plus A minus Z of Mn minus mass of nucleus into C square in joule. Binding energy is equal to ZMP plus A minus Z of Mn minus mass of nucleus into 931.5 mega electron volt, where MP mass of proton, Mn mass of neutrons, capital M mass of stable nucleus. Binding energy per nucleon is equal to binding energy upon A. Packing fraction is equal to M minus A, यानी कि mass defect divided by A. It means delta M over A, where M is the atomic weight and capital A is the atomic mass in AMU. If the packing fraction is negative, the nucleus is more stable. If packing fraction is positive, the nucleus is stable. Packing fraction is 0 for C6C12. Binding energy curve. The curve obtained by plotting the binding energy for nucleon versus mass number is known as binding energy curve. And this is the diagram between binding energy per nucleon versus mass number. Now, the main features of the binding energy curve. The number 1, binding energy is high in range A 28 less than A less than 138, means A must be greater than 28 and less than 138. Light nuclei such as of hydrogen combine to form heavy nucleus for greater stability. This process is called nuclear fusion. Heavy nuclei with A greater than 220 are highly unstable and breaks into two nearly equal nuclei which are stable, and this process is called nuclear fission. The most stable nuclei are those with the largest binding energy, near iron and nickel, where with A nearly equal to 56. With increase in the mass number, binding energy per nucleon first increases rapidly and reaches the maximum value. For 26 iron 56, and its value is 8.8 mega electron volt per nucleon. Then thereafter, increase of binding mass number, binding energy per nucleon decreases, and for uranium 238 it decreases to 7.6 mega electron volt per nucleon. Very light nuclei are least stable. Very heavy nuclei are unstable, and the nuclei with intermediate mass number are more stable. The decrease in the binding energy per nucleon for heavy nuclei is due to the characteristic electrostatic repulsion between the protons. Binding energy per nucleon for helium nucleus is about 7 megaelectron volt, and if A greater than 56, then nuclear fission is possible with the release of energy. If A less than 20, nuclear fusion is possible with the release of energy. Nuclear energy is released in fission because binding energy per nucleon is greater for fission fragment than initial heavy nucleus. Minima are associated with nuclei containing an odd number of protons and neutrons such as 1h3, 5p10 and 7n14. And the maximas are associated with nuclei having even number of protons and neutrons such as 2he4, 6c12, a216. Means even nuclei are more stable, as there are, you see, there are kinks in the graph and the nuclei corresponding to the peaks are more stable. In the nuclear fusion process, energy is released because binding energy of the heavy nucleus formed as a result of fusion is greater than the total binding energy of the lighter nuclei which are fused. Iron, whose binding energy per nucleon stands maximum at 8.7 megaelectron volt per nucleon, is most stable and will undergo neither fission nor fusion. Now, there are some MCQ type of questions on the basis of this chapter or this topic. The difference between the mass of the nucleus and the total mass of its constituents is called dash. Number A, packing fraction. Number B, binding number. C, mass defect. Number D, mass energy. And the correct answer is mass defect, because we have studied mass of nucleons minus mass of nucleus is called mass defect. Then we have the second MCQ type of question. If m is the atomic weight, a is the mass number, then m minus a over a represent dash. The answer A, mass defect, B, packing fraction, C, binding energy, D, chain reaction. And the correct answer is packing fraction, because we have just studied that delta m over a is equal to packing fraction. ਮੈਨੂੰ ਤਾਂ ਕਿ ਮਾਸ ਡਿਫੈਕਟ ਦਾ ਕੇਸ ਲੱਗਿਆ ਕੋਰਟ ਦੇ ਵਿੱਚ, ਜਿਸ ਜਿਹੜੇ ਸਟੂਡੈਂਟਸ ਨੇ ਉਹ ਲਾਇਰ ਹੈ, ਇੱਕ ਲਾਇਰ ਜਿਹੜਾ ਹੈਗਾ ਉਹ ਨਿਊਕਲੀਅਨ ਦੀ ਸਾਈਡ ਦਾ ਹੈ ਔਰ ਦੂਸਰਾ ਜਿਹੜਾ ਲਾਇਰ ਹੈ ਉਹ ਨਿਊਕਲੀਅਸ ਦੀ ਸਾਈਡ ਹੈ, ਔਰ ਜਿਹੜਾ ਟੀਚਰ ਹੈ ਉਹ ਜੱਜ ਹੈ। ਨਿਊਕਲੀਅਨ ਦਾ ਜਿਹੜਾ ਲਾਇਰ ਹੈ ਉਹਨੇ ਕੋਰਟ ਦੇ ਵਿੱਚ ਕੇਸ ਕੀਤਾ ਕਿ ਜਿਹੜੇ ਮੇਰੇ ਕਲਾਇੰਟ ਨੇ ਜਦੋਂ ਕੰਬਾਈਨਡ ਜਿਹੜਾ ਨਿਊਕਲੀਅਸ ਜਦੋਂ ਐਂਟਰ ਹੁੰਦਾ ਤਾਂ ਮਾਸ ਇੰਨਾ ਹੁੰਦਾ ਕਿ ਮੇਰੇ ਜਿਹੜਾ ਨਿਊਕਲੀਅਸ ਹੈ ਉਹਨੇ ਸਾਡਾ ਕੁਝ ਮਾਸ ਚੋਰੀ ਕਰ ਲਿਆ। ਜਦੋਂ ਨਿਊਕਲੀਅਸ ਦੀ ਵਾਰੀ ਆਈ ਉਹਨੇ ਕੋਰਟ ਦੇ ਵਿੱਚ ਆਰਗੂਮੈਂਟ ਦਿੱਤੇ ਤਾਂ ਉਹਨੇ ਕਿਹਾ ਵੀ ਮੈਨੇ ਮਾਸ ਜਨਾਬ ਚੋਰੀ ਨਹੀਂ ਕੀਤਾ, ਬਲਕਿ ਜਿਹੜਾ ਮਾਸ ਹੈ ਉਹ ਬਾਈਂਡਿੰਗ એનર્ਜੀ ਚ ਕਨਵਰਟ ਹੋ ਗਿਆ, ਕਿਉਂਕਿ ਜਦੋਂ ਇੰਡੀਵਿਜੂਅਲ ਨਿਊਟਰੋਨ ਤੇ ਪ੍ਰੋਟੋਨ ਸੀ ਉਹਨਾਂ ਦਾ ਆਪਣਾ ਮਾਸ ਸੀ, ਪਰ ਜਦੋਂ ਕੰਬਾਈਨਡ ਹੋ ਕੇ ਗਿਆ ਤਾਂ ਉਹ ਮਾਸ ਜਿਹੜਾ ਸੀ ਕੁਝ ਘਟ ਗਿਆ, ਤਾਂ ਉਹ ਜਿਹੜਾ ਡਾਲਟਾ ਐਮ ਬਣਿਆ ਉਹਨੂੰ ਅਸੀਂ ਜਦੋਂ 931.5 ਨਾਲ 0.5 ਨਾਲ ਮਲਟੀਪਲਾਈ ਕਰਾਂਗੇ ਤਾਂ ਮੈਗਾ ਇਲੈਕਟ੍ਰੋਨ ਵੋਲਟ ਦੇ ਵਿੱਚ ਉਹ ਬਾਈਂਡਿੰਗ એનર્ਜੀ ਬਣ ਜਾਏਗੀ। ਤਾਂ ਜੱਜ ਨੇ ਯਾਨੀ ਕਿ ਟੀਚਰ ਨੇ ਆਰਗੂਮੈਂਟ ਜਿਹੜਾ ਕੇਸ ਸੀ ਉਹਨੂੰ ਡਿਸਮਿਸ ਕਰਤਾ। ਯਾਨੀ ਕਿ ਰੋਲ ਪਲੇ ਦੀ ਮਾਸ ਡਿਫੈਕਟ ਕੋਰਟ ਕੇਸ, ਸਟੂਡੈਂਟਸ ਆਰ ਦੀ ਲਾਇਰ ਆਰਗੂਇੰਗ ਇਨ ਦੀ ਕੋਰਟ ਕੇਸ with one side representing the separate nucleons, protons and neutrons, and on the other side representing formed nucleus. Scenario: nucleons are suing the nucleus, claiming some of their mass was stolen when they were brought together. Question: for the liar representing the nucleon, my clients entered the nucleus with a combined mass of 14.11550 U as nitrogen 14. Present your argument that the nucleus has lower mass and has illegally taken away from my clients. Where did the missing mass go? For liar representing the nucleus, counter the opposition claim by explaining the concept of binding energy. How was the stolen mass converted into energy that hold the nucleon together? Why is this a natural and necessary physical process? The judge, the teacher, considering the evidence, what is your ruling on the case? Base your judgment on the principle of mass-energy relationship and the concept of nuclear binding energy is explained. Thank you.